in section 3.2, we switch from exponential, then we move to our logarithmic functions, which is the inverse function of an exponential function. Okay, the definition of this is going to be y equals log, this may be hard to tell, but that's a base b of x. It's equivalent to b raised to the y equals x. So let me rewrite that so you can, y equals log base b of x, and it's equivalent to the exponential form, which is this format. It's hard to see that here. So we have our logarithmic form and our exponential form. And occasionally you'll be asked to switch from one form to the other, back and forth. And so our very first one, we're going to say, write these equations in its equivalent exponential form. So we want to take it from logarithmic form and rewrite it in exponential form. For those of you that tend to like patterns, and that's the way you see and visualize things, we're going to say this raised to this equals this. So that would be 4 squared equals 16. Now let's see that it matches up with what we're saying. What is the 4? Right here, this 4 is the b. Well, if you look, that's our base over here, so that's why we start with 4. What is the 2? In this particular case, yeah, it's the y. Okay, so y. And the 16 represents the x, so we can see that. So if you compare it back and forth, but like I said, for those of you who prefer the pattern style, so it's going to be 4 raised to that equals this. So you would get 4 squared is equal to x, in which in this case we can answer that and we would just get 16 is equal to x. Okay, the number 3, it's going to be this raised to this equals this. So it's our base raised to the y equals 64. So b squared equals 64. So what's that? How do we solve for b? Take the square root of both sides, so then you're going to get b is equal to, don't forget, plus or minus 8. Okay, now we're going to do the opposite. Let me rewrite just so you can see the equations on this side. I'll write them. If you want to go ahead and start working 4 through 7, you can. Log base b of x, and then b to the y is equal to x. So now they want us to take it from exponential format and give it in logarithmic form. So this one's just going to be log 6 to 16 is equal to 3. Now let's make sure you transition that correctly. 6 is going to be the b, so that's why we want to make sure it's the b here. The 3 is the exponent, so 3 is the y, so equals 3. X. Also, if it's kind of confusing you, remember this. It doesn't matter if I say equals y on this side or equals y on this side. These two are equivalent statements. However you prefer to view that, it's up to you. If it makes you more comfortable to have it in this, you can do that. All right, so then the next one we would get log base 2 of x is equal to 3. Now, if you're like me, I actually prefer the other format better, so I check myself by saying this raised to this equals this, and ask myself if that's what I started with. 2 to the third equals x. 2 to the third equals x. And I check myself in that way, just because that's what's more familiar to me, and it's just the one I prefer to use to check. So let's look at number 6. We've got to do some work with that. First of all, this is not an exponential form. How can I rewrite that in exponential form? The cubed root of 343 is the same as 343 to the 1/3 power. Okay, so if I rewrite that is equal to 7, now I want to use this to write in logarithmic form. So that would just give us log of 340, base 343 of 7 is equal to 1/3. And I check myself. This raised to this equals this. Yes. All right, and let's look at number 7. So we have log 2 of 1/4 is equal to -2, and I want to check myself. This raised to this equals this. So all we did in this first portion was practice rewriting from equivalent forms, switching from logarithmic to exponential, and then also from exponential to logarithmic. Okay, now let's move into actually evaluating some of the expressions. I'll say evaluate without a calculator, because later, in a few lessons later, I'm going to teach you how to be able to evaluate this in a calculator. But right now we're learning how to work with these expressions. So this is going to be like equals what? Okay, so it would be 2 to the what power equals 4. So it's like 2 to the what equals 4. So what would you say our question mark is equal to? 2. Good. And then here, it's like saying 10 to the what power equals 10. So it's like 10 what to the raised to the what power is equal to 10. So what goes there? A 1. So we would say the answer is 1. Now this, let's rewrite. Because it's not in an exponential form, this is the same thing as 3 to the what? What's the known? This, yeah, the known index of a square root is a known 2. So this is to the 1/2 power. Okay, where if we look back up here and it was a 3, then the exponent was 1/3. The known index of a square root is 2, so the exponent would be 1/2. And then we would say 3 to the what power is equal to that. So what will we have? 1/2. Good. So the answer is 1/2. Okay, so now we can use these expressions to calculate. All right, we want to now graph logarithmic functions. First of all, if you remember back in 3.1, we did this function, this f of x, but we want to show that it's the inverse, that these two are inverse, and we want to see them on the same graph so we can compare that in a graphical sense. Okay, so let's go ahead and do xy tables for both of these functions, and I'm going to pause it and do that. Okay, particularly I've picked values for x. I want you to solve for y, plugging it into here. And we've done this one before, so we'll just fill those in from the previous lesson. And this one you can see these values here. Okay, so we get -2, we have 1/4. Okay, so with these values plugged in, we have this, and I just need to go back and graph this function, so I'm going to pause and graph it. Okay, so comparing these two graphs, we can see that they are inverses of one another. And we'll remember back to the inverse section, we said the domain of f of x is equal to the range of f inverse of x. So we can see that happen. Remember the x and y coordinates change on inverses? So this exactly matches this and vice versa. So we can see that these are in fact inverses, and the graphs of these inverses actually look like this. So we wanted to see that these were in fact inverses in a graphical sense. When we talk about domain and range, before we've talked about domain of all polynomials, we talked about domain of a rational expression. We talked about domains that had radical expressions. So now we're going to add logarithmic expressions to our list of domains. So find the domain of a logarithmic function. And so we want our argument to be greater than 0. So our argument is going to be this value right here that's in this parenthesis in this particular one. So to solve for the domain of this one, we're going to say x plus 9 must be greater than 0. Okay, so then we solve this, and we know that x must be greater than -9, which if we were to put this in interval notation, it would be from -9 to infinity. So the domain of this is going to be from -9 to infinity.